learning differs from traditional programming, followed by a complete description about the feature set, including what we mean by features, and what are the different type of data types that can be included as part of it, how to measure it, and how to make it useful. Okay, and then it will be followed by the brief description about the different kinds of algorithms that are supported in machine learning. To start with, let us understand the difference between traditional programming and machine learning. In traditional programming environment, to a computer, which we call as a system, we developers will write the program, right? So you and me or the developers will be writing a program which is just a sequence of instructions to say what needs to be computed, right? This program will operate on a set of inputs, which we call it as raw data, right? So this data will be operated over this program and you will get an output according to the program we write. So here, as an example, I have given a simple program to calculate the sum of two numbers in Python. This is a sample program which we normally write, and to this program, this is actually a sample input, right? So when this input is given to this program, this computer will compute or execute, and it will give the output as 11. This is a normal programming environment. To any user, whoever be it you or be it me or be it anybody else, whatever input I give, this program will behave in same way and it will give the output, right? In contrast to this, what machine learning will do? To a system which operates using machine learning, we don't need to give the program as your input. Rather, we used to give a collection of data along with the output as the input. So these data along with the output will be analyzed by this system using different intelligent learning algorithms, and a program will be computed for it. Right. What is this program? This program will automatically be constructed based on the data and the output and a pattern that is being learned from that environment. So once this program is being constructed, to this new program, you can give a similar data and which is expected to give a same kind of output what we have used for training the system, right? As an example, you look at here, I have given a sample data set, right? 5 and 6 are my input. I am giving 11 as the output. 5 and 60, 56. Similarly, 0 and 4, 4. If you look at this, how does it look like? It's an input which just adds. This input gets added and you are getting an output, right? So what this computer will do, which is working on machine learning algorithm, it will try to identify the kind of operation or the relation between this input and output through different scenarios, and then try to compute a program of this kind. So actually a program of this kind won't be constructed. So it will be in the form of some weights or number, which will rather, that is some equations which we will be looking at in the subsequent lectures. But for an understanding, I have written that it's a program, right? So this is the major difference between your traditional environment and your machine learning environment, right? So if this program data is given to you, whatever human brains will think, it will try to automatically find the relation between input and output. How does we do? We try to do it with different kinds of troubleshooting, right? So we do that, and finally when we arrive at a conclusion that this is how it operates. Similar to that, the machine tries to learn by itself. But keep in mind that the machine can't do anything of its own like a human being. For that, we have to write intelligent programming techniques for making the machine to learn this kind of different environment. So that's where we end up with this course today, that is learning of machine learning algorithms, right? So having completed this, or having an understanding on this, we'll move on for a clear definition on machine learning. So what is required for machine learning? 3 different components. The first one is we need to know what task we need to do. See, a person without a task is of no use, right? So a computer without a task is of no use. Any algorithm has to serve a purpose. That purpose is what we call as a task. So here we have taken a sample example whether the person will like the movie or not. So how do we say whether the person will like the movie? It is by using his history, right? We will try to understand his watch history. We'll try to understand what kind of movies is he looking at, what are the reviews and the ratings that he is giving, and a lot of different other aspect, how much of this particular movie type he is trying to give. All those things we will try to collect, and that's what the experience states. Okay, and then this is very similar to a human being, wherein how do we respond to a particular incident? It is by using our own experience. That experience has to be stored here, like how the experience is stored in a human brain. Right? So this is the important parameter. This forms the data set. If you are trying to store the data about a particular entity, that becomes the data set. Over the data set, we are going to perform a task. Okay, I have the data set. I have performed a task. How do I ensure the quality of the task? That's the next step, right? Because anything without ensuring the quality is of no use. When if I say that a person will like the movie, how will you ensure it? Okay, so that's done by the third parameter called performance. How do you measure the performance? There are different metrics that are available over here, and we'll be looking at shortly, and that's what is defined by a machine learning expert as the classical definition of machine learning. A computer program is said to learn from experience E. That's what we are doing. About what? About the task T. Okay. So, and this particular task T, the results of this task will be measured by this performance P. Okay. So, that is a different kind of metrics we'll be looking at. So, moving on, when to use this machine learning and when not. See, it's obsolete to state that I'm going to use a machine learning to calculate Celsius to Fahrenheit or to convert US dollar to a Indian rupee. Okay, so when to use this? Okay, when a task cannot be done by a human expertise, when there exists a criticality in any operation, be it in the sense of a huge volume of data or in the sense of any other physical pandemic, we can go for this machine learning, right? So, for example, a robot is designed to go and serve people in a critical situation. So that's also one kind of expertise. A task that will consume exhaustive human expertise. See, provided with this much of computational support, it's not always good to use a human being which will consume exhaustive timing. Okay, so that's what. So we should not waste the human power. That's where you can use. So when a task cannot be explained by a human expertise, not every task or the result can be given. Otherwise, what will happen? Say this COVID-19 pandemic, lot of data sets are being released by the government for the use of researchers to come out with the result. Why? Because human beings are not able to analyze that much data and to come out with the explanatory result. Okay, so that's where we end up with the requirement of machine learning, that is intelligent machines. So there you can use it. Then the task needs to be adaptive to different entities. See, in the first slide itself we have seen a traditional program, irrespective of the user, whoever it is, given an input, it will give the same output. If you are giving the same input, it will give the same output. But it's not always required over here. If you look at so many online shopping sites and the Book My Show, anything you take, depending on the person's individual interest, it is giving you recommendations, right? See, that's what in an adaptive environment, machine learning would be of use rather than the human expertise. And of course, on a large data where human being can't use. So these are probable areas where you can employ your machine learning, right? Now, okay, we have seen what is machine learning and how do we store the experience, okay? So that's where we call it as the features or attributes. In session 1, we have talked about or we have discussed about the COVID-19 features, right? What are the set of characteristics that are going to affect a particular task becomes your features or attributes, right? Okay, so yesterday we have seen what are the different features we have considered. Fever, whether it is present or how much it is present, right? How many number of coughs you are getting per minute, Third would be whether you have problem in breathing. Fourth, whether you have muscle pain, tiredness. Some of the features are that name of the patient, address, and whatever you want to collect becomes the attribute. So this attribute set will be common for all the entities that you are going to have as the experience, right? Now, having known that we are in need of feature set, or we are in need of the data set having the values for features, how do you measure that? There comes the scales of measurement. It has 4 different scales. So, lot of different scaling are there. We discuss important concepts. One is the nominal scale, wherein if you categorize something to be, let's say, the sex of a person will be indicated by means of male or female. Okay, there is no difference or no particular ordering between male or female. Both are one and the same, right? It's just for grouping. That's where we end up with nominal scale. Otherwise, suppose that if I want to have the feedback from all of you regarding my session or to want to improvise myself, what scaling you will use. So, I need to get your input in the form of very high, high, fair, bad, very bad, right? So, the very high is not always equal as high because there exists a relation or ordering between this scale. That is where we end up with ordinal scale. Third is your interval scale. So interval in the sense, two datas can be added or subtracted. Okay, for example, if you are fond of cricket, how many number of catches are done by a particular cricketer X in between this year and that year? So you can perform a cumulative things of that. So that kind of data collection is what we call as interval scale. And the last one we are going to see is ratio scale. Ratio scale is when there exists a multiplicative relation between the datas. Okay, let's say yesterday the temperature of a particular city is this much. Today it is that much. What would be the increase or decrease proportion? Okay, so when you list out the features, let's say fever or anything, you can map each and every feature to any one scale. Mostly in machine learning, we assume that the data are independent, the experiences are collected independently, and hence nominal and ordinal scale will mostly be used. But coming to the types of data that you can store on the cells, you see the first type of data, it is in the format of a matrix, right? So this A to E are what we call as the features or the attributes, okay? And the first row corresponds to the experience of entity 1 and the second row corresponds to the experience of entity 2. Okay, so whatever be the entity number, let's say it is 1 lakh or 1 crore, doesn't matter. You only can fill up the data for these values. If you want to extend one more attribute, well and good, you can extend for all entities. So this kind of data is what we call as a structured data. It's quite easy to work on this data because any data can be accessed by means of its index, right? This is another kind of data which we normally used to give in the form of a review or something. So there are sentences like you are looking good, all the best, what are you eating? This kind is what we call as unstructured data. It is quite difficult to work on it, but not always more difficult and not possible. But compared to structured data, working on unstructured data takes a bit of interest to work on, right? Coming to structured data, what are the different kinds of data types that is supported? All those things whichever you want, number, both integer as well as your float, string, both character, boolean, date, images and many more. Based on what kind of data type a particular data set is having, algorithms are evolving. Talking about the different type of data that can be part of your experience, that is your data set, there are two major categories. One, the values could be continuous in the sense that you can have the values lie between a range. Let's say 0 to 1 might be the range. You can have even values like 0.02 and you can have values like 1 or 0.99 or 0.98 or anything. So if you look at the output, what we say, it will range, it will have series of values or continuous values. That's what we call it as continuous. And the second kind of data that you can have is a categorical data. So in the sense that all the output values will be discrete, or if you take the unique values among the output, it will always be finite, and it could be either number like 0, 1, 2, or strings like yes, no, level 1, level 2, or anything else, right? Then how do we know the category? It depends on the classes that we identify pertaining to a domain. Let's say in the COVID-19 dataset, our output is whether the patient is affected with the COVID or not. Okay. So what are the outputs we finally get? Yes or no. So these are the two values, hence it falls into a categorical data. If so, coming to this categorical data, it could be binary. As we have seen in the example, the output is yes or no, right? So it is falls into binary class. It could even be multi-class in the sense, let's say, if the level of seriousness has to be posted in the range of 1 to 5, whether all the patients are given with level 1 to level 5 seriousness, then it is a multi-class data. So these are the type of data that you can have on your experience, which is otherwise called as your data set.